and then department location, and dependent. So let's have a look where it's already been created with some data. So the top one is employee. This is department location, department, works on, project, and dependent. So you may ask that why its data is there. Because today we are we'll try to learn relational algebra, which needs basically the effect of data or change of data. So whatever we'll do the calculus, that needs a certain change, and that change we'll realize if there is data in the table. So we'll look into this design for so many times today. Okay, so again, I'm mentioning we will try to complete up to tuple relational calculus, not domain relational calculus. So domain relational calculus will be taught by professor, and for your phase 2, I guess tuple relational calculus is good enough. So when we'll see a lot of the examples, then it will be much clearer to you. So start. Relational algebra is basically a basic set of operations for relational model, and algebra expression are like sequence of relational algebra operations. So if I'm saying and relational calculus is higher level of declarative language of specifying relational queries. So all of the symbols we'll try to use, and then we'll for some section we'll just make a certain expression, and all of the expression will merge into calculus. So if it's like only the symbol, then here it's like one entity between one entity, or some symbol or some sort of two entities connected with how many symbols will be like there. And in the calculus, ultimately you are using the total query, like select blah blah blah, with conditional queries, and ultimately retrieve the final output data by calculus. So database set of company, here it's more clear, I hope. So employee table has one primary key, SSN, social security number. Department has its own primary key, D number, and department location has D number and D location. Project has its own primary key called P number, and works on has ESSN PNO, and department has ESSN and department name as a primary key. So it's a nice example, you can assume what's the relationship between employee and project. Because in works on, it has the primary key of employee as well as project. So we can say that this works on basically a relationship, and these two are the entity. So that's how you can understand that which tables is for relationship and which tables are for entity. So why? So it's not every time the relationship needs to become a separate entity. Here it needs, because there the relationship is many to many. When it's many to many, then there will be this relationship becomes a separate tables, and from the entity, the primary key and the other entity, the primary key, will go this relationship, and that will be a separate entity. And ours was the relationships itself attribute. So why I'm explaining this? Because in your project, I'm expecting three things, obviously: one-to-one, one-to-many, and many-to-many. So when you are trying to build up one-to-one, then there is no like these things, and there's a relationship, and this another. So if it's one-to-one, that doesn't, and I'm assuming it has its own attribute. So if it's one-to-one, these things doesn't need to have a separate table. But if it's one-to-many, still from one side the primary key will be shift into there and become the foreign key, right? But when it's many-to-many, then this relationship needs to be a separate table, and which will take this primary key, and its own key as well. So here works on is that piece. Okay, so relational algebra, again, basic set of operations, blah, blah, blah. So, unary relational operation, which is select. It's a select operation, but when it's conditional. You always mention that this symbol you will use when you need to select something conditional. If you just want to select salary, then this is not the symbol. Then this is just symbol. When you have no condition. So this is when no condition. And this is for conditional case. So you can see an example like to select the employee tuples whose department number is 4, or those whose salary is greater than 30,000. So we have two clauses together. One is whose department number is 4, which is like this, and whose salary is greater than 30,000, which is like this. So sigma and my conditional case and my targeted entity. Again, this symbol, you can see like this symbol sigma is used to denote the select operator, and the selection condition is a Boolean expression specified on the attribute of relational R. So if it's the whole table, then my condition was department should be 4 and salary has to be greater than 30,000, right? So here department is 4, only these two, and salary is one of them is 25,000, one of them is 43,000. So only this tuple is going to be selected just because of these two conditions. Unary relational operations. So select conditions, we have more examples. Here it's like when the entity is same, like the table is fixed, then condition can be in any way. Here table is fixed, called R. So if it's one condition, two condition, you can call the first one first and second one later, or second one in the first two and first one later, or maybe three together, or maybe second one first, third one, and then first one. So the sequence doesn't matter when it's in the same table. But when it's two table or three table together, then we need to think about it. So like for example, here we're trying to select all the columns from employee, and where the condition is department number is 4, salary is 25,000, and department number is 5, or and salary is greater than 30,000. So then those all are selected. Why all columns returned? Because we are just saying only the condition. So when we are saying only the condition, that means you want to return all of the columns from that table. Now project operation. Project operation is more like specific selecting anything or projecting anything. If I'm saying by the sign and L name and last name and first name and salary of the employee, then there is no condition. I'm just selecting all of the last name, all of the first name, and all of the salary. So our main table was like this, these things, the whole table. This is the employee whole table. And when I'm saying pi of last name, first name, and salary, then only last name, first name, and salary will be selected. Rest of the column, I have no interest in right now. So that's all. Now, if it's like, it's a very good important point is like when you are selecting anything, it removes the duplicate any tuples automatically. So like a lot of the duplicates, duplicates mean whole of the column needs to be duplicated. If you can see like there's nothing I can treat as a whole thing duplicated. Like in salary, 25,000 and 25,000 is similar, but still they're not whole tuple is duplicated because the name is different, right? So when everything is similar, then it trims automatically and take the distinct one. So later on, project operation properties. So a lot of the things that we need to remember as well. Like here, again, if it's a same table, then list of first column or second column or third column. If this is the table and there's like first name, last name, and salary, it will return the same number of the result as long as it has the same number of tuples. There it means like pi of list of 1 and pi of list of 2. So pi of list of 1 as long as the list of 2 contains the attribute of list of 1. So if it's the same table, only the duplicate will be gone. So that's the thing. I think it's like a more theory. So we'll realize when we have see some example. But this is important thing. Page number 13. So third bullet point, page number 13. I'm mentioning this because when I took the course, I really confused with this. So and that's what I did mistake later. So you can see the change right now, which is when I'm saying the projection of L name, H name, and salary, then 1, 2, 3, 4, 5, 6, 7, 8. But when I'm saying the projection of sex and salary, then 1, 2, 3, 4, 5, 6, 7. So 1 is missing. So that means when I'm selecting this, I'm finding one of them are repetitive. Like f of 25,000, it's 2 times. F of 25,000, F of 25,000. But when I'm selecting these 3 columns, then there's no repetition. So that's why this result is 8, but this result is 7. So this is the perfect example of the previous page. Now, the thing is, we can rename the stuff. Yeah. So unary operation of these 2 we have completed. Now these things, we can rename the stuff. Why we need to rename? That could be one question. So we want to rename because when you have 2 queries together, then you can probably start to build up one and one first, or if it's 2 queries, it's too simple. If it's 3 queries together, like nested, very nested, then you should start with a simple portion first, and then the second portion, and the third portion. So every little step, you can rename the whole things within a name that you will realize later, and then you can join them. For example, here it's example to retrieve the first name, last name, and salary of all employees who work in department number 5, and That's it. So here's two things together, like we have to retrieve first name, last name, and salary, and at the same time, employees who work under department number 5. So department number 5, we first select like in a conditional way. Department number is 5 of employee table, and we put into a rename as a DVP5_EMPS. This is completely user defined. You can say whatever you want. Like I can say Naima1 equal to something, but that's not meaningful. And when you're designing, it's like 20 tables and, for example, 3 nested queries together, then it's hard to see or hard to understand what does it mean. So it has to be meaningful. So like here, department now got 5 of employee table. When I'm saying DEP_EMPS, then it's easy to say that, okay, fine, what does it mean? And then in result, we put that projection of a first name, last name, and salary, and this projection is from these things, which is ultimately these things. So it's like more calculus, right? I think everyone learned from the school, like in x 2 plus 3, then y 4 plus 5. So what is x plus y, right? So it's kind of masking. These two things we are putting a rename as a x. So these things we are just putting into a, or declaring a variable, something like that. But this is the one of the most important or most regular thing, renaming, which you will use later. Because when you are using so many things together, then only renaming can help you to see it simpler, very simple. But if you put all the relationships together, then it's very hard to understand that what's going on. But when you are renaming with that very short expression within a variable, then next just you will link those up. Later on, so this renaming factor or operator can be expressed by this thing.
Row,
right?
yeah.
So here it's saying the same thing, what I'm trying to say, and then we're seeing another example. Like this same example is kind of here. So department now is 5, and all the names from there. So where department now is 5, and I'm trying to project from there only the first name, last name, and salary. So when I'm saying only these things, then this whole thing is returned. And then from there, I'm picking these things. So now we'll move into union, which is there. I think it's also elementary school stuff. It was easy for me to understand by this symbol, so I'm sharing. Like this is R, and this is S. So this portion will be R intersect S, and this whole portion is R union S. And if I'm saying R minus S, then only this portion. This portion is R minus S. As well as if I need to say S minus R, then only this portion. So you can remember it by picturization, and here you will remember by the data. That's the difference. So union operation is set of the result of this operation denoted by R union S is a relationship which includes all the tuples from the either R or S. So R and S you can treat as an entity. So let's see an example. To retrieve all the social security numbers from all employees who either work in Department 5 or directly supervise an employee who works in Department 5. Lot of work. So either all employees who either work in Department 5 or directly supervise an employee who works in Department 5. So now I can say this whole, if you can retrieve this small part and then rename and then union together, two things. So first, employees who works on Department 5. That is the first line they try to implement. Department 5, so sigma, right? Conditional. Department 5, and then projecting this from this set of the data and projecting only the SSN number. And then from there, it's result 1. And result 2, I'm taking the super SSN from department of this result things. From this result thing, I'm not taking only the super SSN. You probably realize there is two attribute. One is called SSN and another is called super SSN. SSN, which is coming from itself, like its primary key of itself, and super SSN, which is like only the manager's SSN. So here, so I'm projecting super SSN from that result, and then if I union both of the result, then it basically means that OR things. These OR things actually mean this union. So when I'm getting any, in your midterm and in your final, when you are getting any of the queries, the first thing you should do is like scattered all of the queries into small part, so that you can, that small part you can convert into a small expression, algebra expression, and then all of the algebra expression you can merge together to convert into a calculus. So result 1 and result 2 both are, result 1 and result 2 has to be time compatible. That's very important. Like when I'm retrieving these things is a result 1, the ultimate return type is SSN. And when it's result 2, this is also ultimate type is super SSN. So if its SSN is integer, then super SSN obviously the integer. Then and only then I can union them. If my first result set returns character and my second result set returns integer, then it's not working as a union. So this line is very important, type compatible. Page number 20. Now relational operations from set theory. So now we'll see that intersection or minus or union if it needs together then. So union example here also, it's a nice example, like it's a student table and it's instructor table. So first name and last name when they are doing union, then 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5. So 7 and 5 has to be 12 normally, but it's not 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1 is gone because of
duplicated.
Right. Who's that? So relational algebra union. So from this given table, we can now see the example of union first and minus operator. I think that is kind of mistake. should be intersect. And I think minus operator you also understand from this portion, like if it's r minus s, then this section. If it's s minus r, then this section. This whole common thing will be gone. So common means like the we just saw the example here. This, right? This is the common row. So when you are doing minus, then if it's student, if it's instructor, then all of the things will be there. Only this row will be gone. If it's instructor minus student, then all of them will be there. Only that will be gone. And if it's intersection, then only remain this and one more.
The last one.
Around this one. So if it's intersection, then only two rows, right? Yeah. So it's kind of easy. So intersection is very easy. We're skipping.
So the same ones. Intersection is going to give you the same, like.
Yeah, intersection, yeah, whatever's shared.
So we'll now see if it's a full set. Then how does it work? Okay. Next thing is Cartesian product, which is this. Cartesian product, it's completely like cross product. I think you guys have been done in elementary school as well. If x, a1 and a2 are e1, very simple. Then s and r. So a1, b1, a2, b2, and blah blah blah. So it's a just normal cross product. Cross product always needs to be
That's you.
like no minus value. So we are dealing with data, so no minus thing will come. Okay, that there, the two operands do not have to be time compatible. Those stuff are very important because when we are just in the exam hall, we don't think about it. The type, it's really confusing for professor as well, because maybe you are meaning something which is not matching with answer. Like when I take the homeworks, I just check with the solution. I don't use my own brain. That why you say that like that. If anybody comes like why my marks is that low, then I check. So, but so it's easy to check the papers. But when you are thinking about to answer, then it's not that easy. So you have to be very careful about type. That's what I'm trying to say. So when we saw the union, then it has to be, and here it do not have to be. So it's the Cartesian product. So let's see another example. Where's the query? Okay. So if female employee from all the employee and the dependents. Okay. So employee dependents is the separate tables, which is only the dependents, all of the dependents who are depend on the employee. But we need to figure it out from employee table who are only female, and then female employees cross with dependent people. So who are only female, I retrieve from there, and those are all dependent. So when those are all dependent. So with female, one of each female employee crossing with all the set of the dependent. here I'm going back to data set again because in your exam, these will be given. So you have to just do the stuff, like these things you need to do. So if it's, we can see from here also, like who is F there, only these three, and dependent table has 1, 2, 3, 4, 5, 6, 7. So each and every 3 female has to cross with this dependent whole table. That's how we got this Cartesian result. These things.
I have a quick question.
Sure.
So for the Cartesian, is that only really for like the weak entities? We don't really need to use it any other times?
No, it's not about that.
No.
It could be anything.
It could be anything.
So just when you are having the schedule, I don't really think there are any weak entity, strong entity stuff there.
Okay.
Because weak entity and strong entity, it's a concept when you are just designing or converting the ER diagram into EER diagram. But after that, one table is just a table. I don't care it's from a relation, the table is coming from the relation or not, it's coming from an entity or not, I don't care. I just need the ultimate output that has to be coming from a relational algebra. So now, very complicated stuff is join. Join looks like so easy because it's very similar to cross product, but it's very confusing. And in join, you can see that a lot of the classification called natural join, left, right, full join, and kind of division. But all of them has their like they're from the same class, so it's a bit confusing. So binary relational operations like a join symbol is like that, almost like a cross, just 2 boundaries totally bounded. And then let's see one of the example. To get manager's name, who we need to combine each and department tuple with employee tuple whose assistant value matches with manager value in the department tuple. So this super assistant actually coming from the manager assistant. So if I want to know who are those particular employees who are manager, then I need to combine this table and this table together, and then I can match up with which assistant is matched with MGR assistant. Then those particular result assistant will be the manager ultimately. So for joining things, you have to find a common attribute which will be working as a join condition. So when I'm joining something, I really need to know which particular entity that I'm trying to join and which exactly attributes are common of them.
So it's like intersection with the condition.
Yeah, intersection with the condition, yeah, but the thing is intersection is very rarely takes which are really common, but in join condition, in terms of data, we are taking also all of them which are not eventually not exactly similar. But in intersection, we are taking only them who are exactly similar in terms of data. But in join, it's all about in terms of column, in terms of attributes. So again, so I need to join department and employee together so that I know that assistant type and this assistant type is similar, and then we got them, which are the result there. So again, if we go back to our main given data, then we can see here's our employee table, and that is our MGR assistant. So we're trying to say this MGR assistant has to be, if there it's common, then so 4, 4, 5, 5. So this one 9, 8 something something. on the common attribute called SSN and super SSN, and then trying to find that in terms of data who are similar, and then resulting data is the output. So equi-join is kind of similar. As I said, it's very confusing. So the result of equi-join, we always have one or more pairs of attribute whose name needs not to be identical. Then have identical values in every tuple. So when you are saying equi-join, then you are using the equal sign. Other than that cross sign and bounded things. Then natural join is also like that, but in natural join, because of each pair of attributes with identical values, we'll have super flows. So we will see the difference, okay? Like natural join, equi-join, we'll see the difference. So when we are saying that to apply natural join the d number of attributes of department and department location, it is sufficient just to write is department and cross product with department location, because we are trying to retrieve all of them. So in department and department location is SSN, D name, D number, manager SSN, and manager start date, and department location is D number and D location. So here it is, only the difference is, so department location, all of them. So result of two natural join operator will be the normal Cartesian product. So natural join and full join, the difference we'll see later. So now union and also union and join condition kind of work similar. You can see it's very important. The set of operations including sigma project, that means pi union and set difference, which is minus, and Cartesian product, is called the complete set, because any other relational algebra expression can be expressed by a combination of 5 operations. So you can see like the intersection of this whole union stuff. So, the intersection is means actually the whole union stuff minus the whole of the minus stuff union together. So again, if we try to think in a picturization way, then the intersection portion is this portion. So, and the minus portion is this portion and this portion. So the whole thing is union. If I'm minus, this is S minus R, and this is R minus S. If I'm doing then this intersection remain. And join condition is also work like this. Like if you are joining something with the S, this is also the same thing as putting the joining condition before and then crossing them. So this is same thing. If you solve your homework like this within a situation of this, then it's same thing. So division is a very, very important. Because as usual, what I did mistake in my time, I always mentioned as important. So division, I always got 0. So this is the thing. For division, example is very good example is this one. So you will be given also R and S, and you have to return T. So your T is R divided by S. So the thing is that 2 will be given. I just need to find this. So I'll try to think from here, and there has to be some type, this type. So A1 is there. So A1, is it similar for, so let's distinct the value are B1 and B2, B3, and B4. So for A1, it's working as a, for A1, is that working for B1? And then A2 is also working for B1, and then A3 is also working for B1. So our resulting factor is B1. Because B4, A4, it's not in our S set, so it has no job. As I'm saying, S will be given, so there is no A4, right? So these two row has no job, so don't confuse with that. Like in my case, I always mention A4 also. Then it's not required. Then again for A1, there is B2. For A2, there is no B2. So in resulting, there is no B2. Because B2 has to be in there for this whole of the three things. If it returns with all of the three things, only then it will go there. So is there anything for B2 for only A2? So these two also got no values. For B3, there's no A1. So also B3 has no value. Only again, these three things is there for B4. So there is this one. I hope it's clear, because he will give in your exam more difficult. So page number 39, very important. Now it is very interesting when they are all together. That's hard. So retrieve the names of employees who work on all the projects that John Smith work on. So John Smith is a conditional factor on, and first of all, when you are getting any of the query, you think first how many entities I needed, entity or tables. It's good to now call as a tables. How many tables I need first. Then how many attribute, now we'll no longer call it attribute, we'll now call as column. So first thing in our mind, how many tables? How I will decide that? Because of if I need to clear about exactly what columns I need, then I can realize how many tables. Retrieve all of the names of the employees. So employee table I need for sure. Who works on the all projects? So then project table I need also. That the Johnny Smith works on, then somehow works on table also I need. Why? Because employee table and project table are connected with works on. And once you are having employee table and project table, those all of the primary key goes into works on. So three tables basically you need. And who work on also. So retrieve only the name. So that's was our second thought, that ultimately how many columns I need to put into the output. That is one, the name. So here, as it's first name, last name, so I'm assuming that how it is. So first, let's decide that who is John. So from that, we are putting conditional things where e-name means employee name, is John, and last name, I think it should be F name. Because it's F name there. So F name will be John, and last name comes from employee. We are doing the row from and rename as a Smith. And then projecting P number, which is works on and those Smith crossing together. So you're seeing in joint section number of columns is doesn't necessary to be similar. Like in works on there's 3 columns, but in Smith only 2 columns, right? Because first name and last name. So first name and last name is now joining with 3 columns. So our whole result will be here 5 columns. Because from works on it's coming 3 and from Smith it's coming 2. So that becomes into there. Now from works on I also need ESSN and PNOM. Why I need that? Because ultimately I will do these things and these things division here. So if I can retrieve from the works on only the SSN and the P project number, P now means project number. So if I can retrieve from project number and employee SSN, and here it's already been returned, which is the Smith's project number and detail, like hours, P number and SSN. So now I have here only the project number and employee SSN and hours, who is Smith, and here I have all of their social security number and project number. Then if I do them division, then I can have only the person's SSN number, which is who is John Smith. So when I did only the division, then I have only the SSN number. Then finally, if I do the project from this employee and because here I have only the SSN, right? So still I need the name. So for name, I need to again go back to the employee and multiply with employee. The SSN S, which is John Smith's SSN. So if I multiply with them, then I will return only the first name and last name of John Smith's who work on all the project. So retrieve names who work on all the project that John Smith works on. I hope it's clear. It's very confusing. Let me explain again. For example, I'm taking Java programming course, and I know a lot of students here are taking also Java programming course. So if I now tell that who are the particular students who are doing Java programming with me, then kind of like this. So in John Smith, I'm there, and then I'm trying to retrieve all my SSN number from these complicated states, and then here I'm just crossing with all of them who are taking the Java programming. So like this. I hope from class it will be clear only 30%, but when you do the homework, then hopefully 80 to 100. So that's how the difference from data. So from SSN, SSN is this portion, retrieving all of them, and then when they are crossing, then ultimately retrieving all of them, and then when you are crossing them in last step, then this is the ultimate result. So let's go back to the data. Let's find who is John. Here it is. So that works on project. Who is the project? Project P number. We have the department number, P number. So John Smith's SSN is 3344 blah blah. So in works on, you can see that 3344 is this. These two. And these two has project number